Alright, we're going to start out with box plots DIY number 1. Hopefully you've already glued this into your notebook and you should see that this is going to go on pages 2 and 3. Well, this is page 1. Put a 1 down in my corner. When I turn the page, these are now pages 2 is on the left, which you can't see me numbering, but I am, and 3 is on the right. Remember, for these videos, you can always stop, rewind, pause, whatever best fits your needs. Alright, so we'll start with our title. Our title is Notes for Box Plots. Now in 6th grade, you did work with box plots a little bit, but they were also called box and whiskers. So they look something like this picture right here. This is an example of a horizontal box plot, and these are examples of vertical box plots. So also known as box and whiskers. They're still basically the same. Well, they are the same thing, just with a different name. So we're just going to pick some random numbers, but I'm actually going to put them in order. So whenever you pick random numbers or you have a set of data, in order to make a box plot, the first thing you need to do is put those numbers in order. So the numbers I'm going to use, and these are just ones I just picked just to go, 6, 12, 15, 17, 20, 23, 25, 27, and 30. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have 9 numbers. So these 9 numbers are the data set for my box plot. Whenever you're looking at a box plot, you have what's called a 5 data summary. Okay, a 5 data summary, and that pen is hard to see. I'll try to write with a different one from now on. Okay, so with your 5 data summary, your 5 data summary, you always start from the inside out. That's how I remember it. So I'm going to start from the inside out. I'm going to pick the median. Okay, so the first thing you're going to find is your median. Well, median is one of those words that you should know from 6th grade and even before that. So the median is your middle number in your set of data. Well, because I have 9 pieces of data, my median is the 5th piece right here. Now, let's pretend you would have had 8. Your median would actually be between 17 and 20. So you'd have to find the number that lies between them, or the average between them. But we got lucky. This one's an odd set, so we have a perfect median. So the median is the middle. The median is also called, well, we'll come back to that. So we have our median. The next thing, which this is very blurry today, sorry guys. Let's see if I can fix this a little bit for us. There we go. The second piece of data is our lower median. Now, that's not really what we call it, but that's how you should think about it. So basically, you cover up the median and everything over. And I say, okay, what's the median here? Well, here I have 4 numbers, so it's perfectly in the middle. Well, the average of these, well, I'd say 12 and 15, that's 27. So 27 divided by 2 is actually going to be 13 and a half. Okay. Now, the lower median was our second piece. Our third piece, if we have a lower, we have to have an upper median. So the upper median is the middle of the upper half. So the upper median, again, fits between 2 numbers, and it's going to be 26. That one was a little bit easier. Now, sometimes the medians can be an exact number. It just depends on the number of pieces in your data set. If you've noticed, this is now broken up into 4 sections. Those sections are called quartiles. Okay, so this is really called your quartile 1. Okay, quartile 1, Q1. Your median would be the second one, or Q2. And then your upper median would be quartile 3. Now, even though these are the labels, the quartile it's talking about is this whole section here, here, here. Now we're not done because I said this was a 5 data summary and we only have 3 of these pieces of data. So our next ones, and these are the ones I suggest you always do last. They are the easiest too. The 4th is the minimum. Pretty easy. What's our minimum number here? 6. And then the 5th is our maximum. So now, which is 30, we have our 5 data summary. The first one was the median, then the median of the lower, median of the upper, min, and max. So the 6th thing to do is to actually make your box and whiskers. Now, this is called a box plot. Let's make sure that we all understand that that's the correct terminology. But when we're thinking about it, it really is a box that connects quartile 1 to quartile 3. And then the whiskers connect the minimum and maximums. So you see there's a box and whiskers. But the correct terminology that we're using is a box plot. Each quartile, sorry about that, each quartile is approximately 25% of the data, which makes sense. It's broken into 4 parts, so it's approximately 25%. Now my light's turned off, so my color got weird. Let's see if we can fix that so you can see it better. There we go. 25% of the data. So each quartile. So between my pen and my finger here, 25%. Here, 25%. Here, 25%. Here, 25%. The whole thing is 100%. The box is 50%. 25 and 25 is 50. Now, each box may look different, but they all still contain the same amount of data. So the quartile size is controlled by the spread of the numbers. Okay, each quartile is approximately 25%, but the actual size is controlled by the spread of the numbers. So looking at this real quick, well, actually I'm going to pick, looking at this one, each piece is still 25%, 25%, 25%, 25%. Don't get confused and say, oh, this is the smallest, so it has the smallest amount of data. Sorry again. So just because it's the smallest does not mean it has the smallest amount of data. It actually means the numbers are closer together. Where the pieces are real long, the numbers are further apart. So numbers close together, numbers far apart, still has the same amount of data. Now, another thing we're going to talk about is something called the IQR. That's how we'll refer to it, but you really need to know that that means inner quartile range. The IQR is the inner quartile range. Now, it's really easy. You know this. So inner quartile. Well, the inner quartiles is this middle section. And range is a word that you should know too. It's taking the smallest from the largest. So the inner quartile range is taking quartile 3 and subtracting quartile 1. You're just subtracting the pieces of the box. So in this case, our quartile 3 is 26. And I'm subtracting 13.5 because that's my quartile 1. So the inner quartile range will be 12.5. Okay? Inner quartile range is you take quartile 3 minus quartile 1. Not too bad. Let's look at one more really quickly to see if we've got this down. So here's a set of numbers. 20, 24, 33, 35, 37, 40, 44, 45, 49, 50. Remember, you can always pause it. First set, 5 data summary. I think about it as my hands. Okay, I'm starting from the inside out. I want the middle, the median. So if there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there should be 5 on one side, 5 on the other. 1, 2, 3, 4, 5. There we go. There's my median. So I have 38 and 39, so it's going to be 38 and a half. Now, looking just at this bottom half. Well, over here I have 1, 2, 3, 4, 5. So there's a perfect lower quartile. Then over here, 1, 2, 3, 4, 5. Perfect upper. Remember, median of the whole thing, median of the lower, median of the upper, minimum, maximum. Draw our box, and there we go. Now, like these pictures, it's not complete until you put it on a scale, but this is the basics. If you understand the basics, you're good to go. Let's find the IQR, interquartile range. What are we going to subtract? Well, we have quartile 3, which is 45, minus quartile 1, which is 33. When we subtract 45 minus 33, 12 is our IQR. Easy peasy. All right, now get out that piece of paper that was in the box. You're going to need that to glue. Okay, what you're going to do now is you're going to turn your notebook sideways. Okay, and when you turn your notebook sideways, you're going to take and glue this on page 2, like so. Okay, so I have my 3 types, and this is me comparing. This is me looking at the shape. This is the shape of my box plots. Shape. The first one is skewed to the right. And what that means is that if it's skewed to the right, most data is in the right. I'm sorry, most data is on the left. Whew, make sure I say that right. Most data on the left. It has a long right whisker. Okay, this is just a description. So because it's skewed to the right, it has this long right whisker. And then the vocabulary piece for this one is the mean is greater than the median. The mean is greater than the median because this skewed part is going to pull the mean to be greater than the median that's way over here. It's going to pull it up. Symmetrical, if you look, symmetrical, that's a word that you learned a long time ago, is that they're basically the same, okay? The mean and the median are the same, or about, okay? It looks symmetrical. The sides look very similar. And then the last one is if it's skewed to the left. Now, if it's skewed to the left, most data is on the right, but skewed to the left means it has a long left tail or whisker. Okay, but the most important part, the vocabulary aspect of this, is that the mean is less than the median. Okay, the mean will be on this left side, which will be less than the median, which is the very middle. So those are your 3 different ones. You'll be able to look at them, compare them, see which one it is. If you notice in these pictures, we have these little dots. Those are called outliers. That means that those numbers are way above or way below the data. So just outliers are numbers that you'll see separately. Looking at some of these box plots, you can see it has a longer left whisker. It's skewed to the left. This one is actually pretty close. It's close to symmetrical. Longer left whisker. These are all pretty much skewed to the left. So whichever side has the longer piece, that's the way it's skewed. All right, make sure that you have all of this and you're ready to move on to the next DIY. Good luck.